Hi. Today, I will show you how to make an X-calibration of a Raman device. For this, we need both a spectrum of a neon lamp that was taken without laser and a Raman spectrum of a silicon wafer. First, we need to load both spectra. Here, I will show you how to load to spectra in ASCII file format. Create a new, empty worksheet using this toolbar button. Then import the neon spectrum. Here, the spectrum is in ASCII format, so we can use the Import ASCII button. After import, you can rename the worksheet, say to Spectrum Neon, but this is only for convenience. The worksheet consists of some columns. Currently, the column Pixels is the X column, as can be seen by the label X0 in the right lower corner of the column header. For us, the column Raman Shift should be the X column. Right-click with the mouse on the column header and set column as X in order to mark this column as X column. Then we can plot the spectrum by selecting the column Process Data and using the toolbar button Plot the selected column as line. The spectrum looks reasonable, so we can use it for neon calibration. Go back to the worksheet containing the neon spectrum and use the menu Analysis, Spectroscopy, Raman, Neon Calibration. There are a lot of options, and most can be left to their default values. But make sure that the unit of your spectrum's x-axis matches the options here. Our X column is Raman Shift, so the default value relative shift in centimeters is fine for us. And enter in this field here the approximate wavelength of your laser. The pre-processing and peak searching and shifting options are already preset for neon calibration. Press OK. A new table which is named W-Raman Calibration is created, which now contains the neon part of the Raman calibration. Here, the found wavelengths of the neon peaks and their correspondence to the NIST wavelength are stored. As I said before, secondly, for a full x-axis calibration we will need the Raman spectrum of a silicon wafer. Create another empty worksheet and import the silicon spectrum into it. Rename it, and choose again the column Raman Shift as the x-axis. Select the column containing the y values of the spectrum. Then, use the menu point Analysis, Spectroscopy, Raman, Silicon Calibration. If known, you can enter the temperature of the silicon wafer during the measurement. At the bottom of the dialog, there is the combo box destination table. It shows the latest calibration table that was used, that is, it shows the table W-Raman calibration. This is the place where the silicon calibration must be stored to. Then press OK. The worksheet W-Raman calibration now contains a full x-axis calibration. The last three columns now contain the uncalibrated x-axis, the calibrated x-axis, and the difference of both axes. Just load another spectrum, here for instance of polystyrene, again select the right x-axis, and then use Analysis, Spectroscopy, Pre-process. In the second tab, choose the table containing the calibration. After pressing OK, the pre-processed spectra now contains the calibrated x-axis. In the help manual, you can find more information on this type of calibration and tips on how to acquire the neon and the silicon spectrum. That's all for today. Start playing with Altaxo now and have fun.